I think you'll find that lesson 60 is pretty easy. We're going to talk about direct and inverse variation. How many of you have done some of these problems before? Can't remember if Algebra 1 had some of those in there or not. So the whole thing is, if it says they vary directly, then we write an equation that A varies directly as B, then A equals K times B. If it's Y varies directly as B, then Y equals K times B. That means as one gets bigger, the other one gets bigger. So if A gets bigger, B gets bigger. If A gets smaller, B gets smaller. A varies inversely as B. We start off A equals K over B. We put the B in the denominator. That means if A gets bigger, B gets smaller. So one gets bigger and the other gets smaller. K in both cases is what we call a constant of variation. And for problem number 1, there's a K, and that K stands through and holds up through the entire problem number 1. But then if we change situations for problem number 2, it's going to have a different K. So each problem will have a different K. Very often we first need to solve and find what K is for that problem. Then we can go on and finish solving. So before we start solving some problems, we're just going to write some equations of what would model this. So if it says boys vary directly as girls, anytime it says varies, we take whatever it is that's before that, whatever it is that varies, and we write down boys equals, and then we have our constant of variation. If it's direct, we're going to do times the next one. If it's inverse, we're going to do divided by the next one. So directly as the number of girls, directly means then we multiply, and then that would be our equation for starting that problem. So who wants to help me with the next one? Charlotte? Very good. So price varies, so price equals, in fact, price equals K. Then we get, because inverse, we need to divide by the n. Everybody write down on your own paper what you think this one should be, and then we'll check and see if we're all putting down the same thing. Resistance is directly proportional to the length. Hendricks, what you write down? Thumbs up, thumbs down. Do you agree with that? I'm seeing thumbs up all around the room. Resistance is directly proportional, means exactly the same thing as varies directly. So I could have varies directly. Synonyms are directly proportional. Synonym here could be inversely proportional. Means exactly the same thing. So good job picking up on that one, on the synonym in the English language. Okay, we'll do a couple more and then we'll go to actual problems. So number of revolutions on this one, so we'll call that R, is inversely proportional to the number of teeth. We'll choose a T for teeth on that one. Write down how you think that one should look. Revolutions inversely proportional to the teeth. Bella, what you write? K over T. They're always, if they're variation of proportional, it's always something equals K, and then it's times or divided by the other one, depending on direct or inverse. And the last one before we go to actual problems, water varies directly as the amount of hydrogen burned. And Anu, what are you thinking for that equation? No, this one's W. Perfect. So thumbs up, thumbs down, feel like you understand the setup on this. Okay, the rest of this is just plugging in and using it. Number of bluebirds in every tree varied directly as the number of redbirds. So we are going to write down our equation for that. So B for bluebirds equals K, because it varies directly. Is it going to be times the redbirds or divided by the redbirds, Alex? We're going to multiply, so times the R. On every problem, then, you're going to plug in what you're given for a first case. So here's the first case, 12 bluebirds and 3 redbirds. So we put in the 12 for the B, the 3 for the R, and we need to figure out what K is. On every problem, I expect to see K equals some number. And then you're going to go on and actually use that to solve it. So everybody shout out, what is K in this problem? 4. K is going to be 4. Then we have a second case over here, which is the one we're actually solving. So here's our case 2. So we now know that our equation is really B equals 4R for anything about these bluebirds and redbirds and trees. As long as we stick with that problem, K is 4. So this is actually our equation. So now we know that there are 6 redbirds, and we need to figure out how many bluebirds there are. So everybody shout out, how many bluebirds do we have?
24 bluebirds.
What do you think? Pretty easy problems? I started off with, I thought you would kind of like this lesson because it is not that difficult. Let's do a couple more together, then a couple on whiteboards, and then homework. So revolutions varies inversely as teeth. We already wrote that down in those practice sentences. We wrote down revolutions is K, because it varies. Inversely meant we divided by the number of teeth in the gear. So then we need to put the 60 in for the teeth. And then we know that R is 150. Multiply both sides by 60. Help me out here with the multiplying. What is K going to be for this particular problem? 9,000. So now we know our formula is really R equals 9,000 over T for anything else going on with this kind of problem. So then we have our case 2 that we're really answering. Well, if there are 100 teeth, what does that mean for our revolutions per minute? So 9,000 over 100, cross out 2 zeros, and we have 90 RPMs. Thumbs up, thumbs down for that one. Okay, for this one, I'd like all of you to write down on your papers, what do you think the first equation will be if clowns directly proportional to the performers? So everybody write down what you think the equation is, and then we'll check that step. Is that what you write down for the formula?
I think C equals to K times Q.
Thumbs up, thumbs down. Okay, now I want everybody substitute in your information for case 1 and figure out what K needs to be for me. And then we'll pause and make sure we've all got the same K. So let's see as a group if we can, now that you've done that on your own, what we can come up with. If we put 40 in for the clowns and 20,000 in for the performers, if I divide both sides by 20,000, I have 1 over 500, which is what most of you got. So thumbs up, thumbs down, everybody comfortable with that? Okay, now that means that your equation for this problem is C equals 1 over 500 times P. So now if you want to write that as P over 500, if you want to multiply the 1 times P and write it like that, that's fine, you don't have to. But now I would like you to plug in the 12,000 performers and figure out for me how many clowns that means that we have. Yeah. So if we plug 12,000 in for the P, keep the 500, that cancels out 2 of our zeros. 120 divided by 5 is going to be 24 clowns. Questions from anybody on how we do these? Yes?
Well, I just noticed you could set up a ratio.
We could, but I want you to do these this way rather than with the proportions on it for now anyway, because this is how you're going to be setting it up in your science classes on these problems, and they're going to expect you to find K. And again, the reason for that is if you are doing the experiment over and over and over and over, just with slightly different amounts of this substance or a slightly different temperature or whatever, you want to just be able to plug it into the formula real fast to predict the results. All right, grab those whiteboards and you guys do a little bit more practice.